Welcome to the Infrastructure Podcast. My name is Anthony Oliver, and today we're diving into the world of digital ground movement monitoring, a rapidly evolving field that's quietly transforming how we manage, maintain and future-proof our critical infrastructure. Emerging into this market is Osprey Measurement Systems, a high-tech business spun out of University College London that's using cutting-edge digital tools to bring greater precision, speed and insight into ground movement, something that affects everything from railways and tunnels to utilities and city infrastructure. To help us understand the technology, the market and the broader implications, I'm joined today by Daniel Scott, co-founder and chief technology officer at Osprey. Daniel's background is nothing if not broad. He's a former lecturer at UCL in civil and geomatic engineering and has worked on major UK infrastructure projects including Crossrail and the Channel Tunnel Rail Link. But he's also a serving member of the 507 Specialist Team Royal Engineers, focusing on railway infrastructure, and more about that later, I'm sure. But in this conversation, we'll explore the journey of OMS as a spin-out company, the power of reality capture and digital measurement to transform infrastructure delivery and monitoring, and what it takes to bring genuinely disruptive technology to a traditionally risk-averse sector. Maybe we'll also talk about how technology like this can shift the performance, efficiency and safety of infrastructure assets. So let's hear more. Daniel, welcome to the Infrastructure Podcast.
Great to be here, Anthony.
Well, for a starter, Daniel, I'd set the scene in terms of what Osprey Measurement Systems is all about. It's a business you started with your brother Peter in 2016. I mean, how would you describe what the business does and what problems you're solving for the infrastructure sector?
So fundamentally, Osprey identifies important problems within measurement for large-scale civil construction and operation. And then we take the latest and greatest technologies that we've identified in academia or in our work with other partners and look at how we can apply that to the measurement challenges we face within infrastructure.
Well, you offer a number of proprietary products. Your in-place extensometer, tilt string and automatic settlement profiler, for example. I mean, how does your digital ground movement monitoring system work? Well, what makes it different, Daniel, from the traditional solutions that are available out there?
So our core kind of USP is the fact that both my brother and I and all of our product managers have extensive on-site experience. We all have worked on the tools for extended periods of time. We've all been at the coalface, so to speak. And our product portfolio really reflects the challenges that we faced in that role. So largely what we're focusing on at the moment with Osprey is how to kind of systematize and take activities that used to be done on site and get those eliminated at the design phase or in the production phase. So by the time stuff arrives on site, it's exactly how that end user needs it to be to get it in, because ultimately time on site is really, really expensive and risky.
Right. Yeah. Well, tell us what kind of infrastructure projects or assets are best suited to your technology? Where are you and your partners currently working?
Yeah, in the UK, the large one is obviously HS2. So a huge amount of earthworks monitoring going on there. And due to the kind of nature of the slab track and the long life, low maintenance philosophy they're following, the geotechnics need to be absolutely on point. So they've been really pioneering in using our systems and making sure that they're getting absolutely the best quality measurement so that when the tier one contractors are handing over to HS2, there's absolutely a real golden audit trail of how the geotechnical structures have performed over wet-dry cycles, and that we know that we can lay the railway down in reasonable confidence that we're not going to have to adjust it too much afterwards for a long time to come. Anywhere
else?
Tailings dams in around the world. So obviously there've been some fairly high-profile collapses. So that's becoming a very big sector, and they're really innovating in how the risk is managed with tailings facilities. It's a kind of necessary part of large scale mining, and the risk mitigations have to really be there because, as we've seen, it can be catastrophic for local communities and the mine operators.
Yeah.
So that's been a huge sector. And then also the large one is retrofit of existing manually monitored systems. So there are tens of thousands of historic instrumentation systems deployed around the world, which traditionally have been too expensive to automate. And we've been targeting those so that we can get automated systems in those boreholes, improve the quality of the data, reduce the necessity of people to go in dangerous environments.
Yeah, so that literally is removing the need for people to go there and physically look at what's going on.
Indeed, yeah. And it gives much better insights. You can spot trends much more reliably rather than kind of condition monitoring. You can also look at event detection, and you can make sure you're capturing or predicting things as they unfold. So rather than monitoring once a month and then a landslide happens in week 2 of that cycle and you don't realise for some period of time or until a member of the public comes a cropper, we can actually start getting alerts to where they need to get to sort of in the hours or days ahead of that event happening.
It's very reminiscent, Dan, because I remember when I was first started out in engineering, I had a job to visit once a month an escarpment down in Kent to dip tape measures down boreholes to see what was going on with slope indicators, etc. You know, those days have gone, I imagine.
Well, I've been exactly there too, and that's exactly what the IPX automates. And there's still a lot of manual dipping.
No, they were nice days out by the seaside, as I remember. So I enjoyed them. But I hear there's some very large earthworks about to start on the east coast at a very large nuclear power station. Is that anything you're getting involved with there?
Indeed. Sizewell C we've got a great relationship with, and they're being really proactive in using the latest technologies, but the latest techniques. The team who are overseeing the instrumentation and monitoring that we're involved with, I'm super impressed at the foresight of what is monitored, what sort of things they're defending against, because ultimately, we need to know that this is going to work for considerable sort of generational periods of time. So the measurement challenges there are really significant. And they've been really proactive in identifying emerging technologies, de-risking them through trials and investigations and making sure they're deployable and that the information is what is useful at the end of the day, and then rolling those out. We've got a few systems deployed with them now, and it's really exciting to be a part of that project.
Yeah, no, certainly. Well, what makes you unique in the market then? I mean, how have your products evolved since you were spun out of UCL as a postgrad? I think it was your postgrad project.
Yeah, that's right. It was my doctoral studies at University College London, developing improvements to instrumentation systems off of the back of my work at Crossrail. So I was involved. I was a project manager, instrumentation and monitoring project manager on Crossrail, deploying kind of millions of pounds worth of automated survey systems and other types of instrumentation. So off the back of that, I wanted to take a bit of a mid-career break. I had some ideas from that of how we could have been doing things could have been designed better so they were cheaper and more reliable to install. There were tasks that were happening on site that shouldn't have been happening. And in the round, these lead up to millions of pounds on a project of that scale, potentially sort of tens of millions of pounds worth of efficiencies that we could drive through better design and of this equipment itself. So since coming out of the laboratories at UCL, that the main thing is really ruggedizing them. So, everyone kind of looks at our business and assumes the hard bit is all of the kind of Gucci maths and electronics and stuff. Actually, the really hard stuff is making 1,000 of them that all work when they've been thrown down a borehole at sort of 3 under time pressure from the drillers who want to get home. And so I dare say when it was designed by me, the electronics and the complicated stuff worked fantastically, but we had real problems with kind of sealing and field ruggedization. So one of our earliest hires was actually to hire a very senior engineer at one of the traditional instrumentation companies, and he took a hatchet to a lot of my design work, and he really ruggedized it, and that's been our absolute mantra now, is just scaling out and how do we make 1,000 at a time that are 100% going to work.
But of course, putting things in the ground to measure is one thing. Taking action is another. I remember 30 years ago, back with to the Heathrow Express collapse. They had great monitoring, but the required action was the thing that was lacking. Is that changing?
I hope so, Anthony. So that was very early on in my career, and that was a real landmark moment. Was that the information did exist? It was just ignored or uninterpreted. And still, I think the industry has a greater ability to output data than to turn that into actionable information. With the advent of AI, that is really changing, and I think we're now starting to get the tools needed for that to come more into balance.
So you really do see a role of data analytics and AI really helping to bring all that together.
Absolutely, yeah. There is a hype machine, undoubtedly, but it's just so ideally suited to AI and what that brings to the party in terms of pattern recognition, kind of multi-factor, multivariable analysis. So we can start bringing in disparate data sources. We can also start bringing in quite, dare I say, noisy data from kind of the soil engineering geotechnics community, where they have to deal with a huge number of unknowns. And up until a few years ago, we just didn't really have the mathematical tools available to kind of deal with that in a robust way. But I feel like we do have those tools now. We do have the background knowledge of soil mechanics and structural mechanics, and now we have the data as well. So it's sort of synthesizing all three of those things.
Well, it sounds like the whole market for ground movement and geotechnical monitoring in the UK and internationally is growing. I mean, what would you say are the main drivers pushing infrastructure clients towards digital measurement systems? Is it cost savings? Is it performance? And is it, as you mentioned earlier, safety, getting people out of harm's way?
Yeah, it is a very fast-growing industry, and it's really exciting to be part of it. And we hope to be a huge part in growing that. We broadly categorize it into kind of measurement during construction to optimize processes, and that would also include analysis of the data after construction. So that's kind of going into the tier one consulting engineers to help inform site activities and future designs. You've then got infrastructure operations. So that's kind of timely data that's coming in and maybe is informing kind of the more longer term operations of the structures, and looking at kind of condition monitoring. And that would also play a part for organizations like Network Rail or National Highways in then grading remediation projects and looking at what's a priority. So it kind of helps with infrastructure management as well. And then there's the alert detection and the kind of real time, something is about to happen or something has just happened that you need to know about because trains need to stop, lanes on the motorway need to be closed, etc. Sort of people need to be removed from the environment. So they're the three key sectors. But all of these are really going to be driven by the reduction in price, and really we're absolutely laser focused on reducing the deployment costs of these sensing systems and increasing the value of the data on the back end as well. So kind of two kind of intersecting graphs, like that's how we're going to grow the market. Yeah,
because there's a high cost in actually installing the kit, or buying the kit and installing the kit. But I imagine there's also as you get more and more data flowing out, there's certainly a management resource required to actually make sure that you are properly assessing that data that's coming out.
Yeah, and this is not something that Osprey get directly involved in at the moment, but it's something that we really want to drive towards, both within our organisation and industry-wide. And I mean, it has historically been a real point of shame, quite frankly, in the industry, of how little kind of respect or value has been placed on this data. I mean, when I went to UCL, for example, I tried to get all of the Crossrail data sets. This is high tens of millions, if not low kind of 100 million figure amount of taxpayer money spent on this data set. So I thought this would be fantastic, beautiful, high density instrumentation data set of central London tunnelling activities. Ended up having to do a freedom of information request on Crossrail. After almost a year of back and forth between UCL legal and TfL legal, finally managed to get access to the data set. to find that it had been largely deleted because it had taken up too much space on someone's laptop, and it was all but useless. So it's intensely frustrating that data set could have been really, really instrumental in Crossrail 2. And, you know, did we over design here? Could we have done it differently here? What impact did it have on the tunnels? And we sort of see it now as well. HS2 in theory is supposed to be giving all of its data to the BGS, British Geological Survey, to administer and look after. They are supposed to be the custodians of all subsurface data in the UK, and all public sector funded projects are supposed to give all of their subsurface data to the BGS for the public good. When I checked with the BGS last year, none had been forthcoming from HS2.
So what's holding the sector back from this wider adoption of data as a resource?
I think, as you say, it's the traditional complexity of hosting and interpreting the data. The sensitivities around it. For example, we wanted to do a publication of tunnelling activity nearby some other national critical infrastructure, and that was kiboshed because owners of said infrastructure didn't want any data about the tunnel and ground interface to their infrastructure to be made public. So there are still sensitivities that I think get in the way a lot of how this data is then used more widely. Yeah.
And are there any kind of within the industry any kind of misconceptions about, you know, the way that digital monitoring works and its capabilities? What other things that are you trying to overcome as a relatively new startup in this sector?
Yeah, I think traditionally these on the sensing side, it's often been very heavy on capex. So traditionally, you would go out and you would buy lots of expensive widgets and shiny stainless steel sensors, and then they would go in the ground. And so the payment's all up front. There's no relationship if you're an infrastructure manager with kind of, actually, I've got to look after this asset for 10, 20 years. Yeah. And sort of it's all going to come out of my budget in year one or month one. We've been working a lot with infrastructure operators who make it very clear that actually to be able to have sensing as a subscription service would really unlock a lot of operational sort of financial constraints, so they can move things into a OPEX rather than a CAPEX kind of bucket.
No, but it's interesting. I was talking last week at a technology conference with Bentley about the way that they're trying to bring the asset management much closer to the project management. So people who are designing are thinking a lot earlier about actually managing and maintaining those assets. And I suppose that in many ways is a nirvana for the sector, because they're traditionally very siloed.
Yeah, indeed. And those digital twins are so important to have those moving into a real-time phase where we can have digital twins that are highly multimodal. And I know Bentley and others are very pioneering now in bringing diverse data sets into the digital twins of large infrastructure. And that's fantastic for us as a sensor manufacturer and a systems designer to be able to have that, because ultimately that generates more value for the data, which is more, it's better for everyone. It doesn't sit under a desk like it did at Heathrow.
Well, yeah. Well, Dan, let's talk more about you and your motivations behind starting OMS. Was there like a light bulb moment when you were sitting there at Crossrail or Channel Tunnel Rail Link thinking this is something which needs to happen?
Yeah, I think like many light bulb moments, it takes quite a lot. There's quite a lot that goes into the background of a light bulb moment, and certainly coming off the back of Crossrail and wanting to look at how we could improve the sensing systems that were deployed there and innovate on that. That was my principal motivation to going and doing the mid-career doctorate. Meanwhile, while I was doing that, my brother had moved to Australia, and he set up and ultimately built the largest instrumentation contractor in Australia. And we were just having very high frequency conversations about his pain points and his team's pain points on site. And we just found a few times, many times we'd discuss nothing would come of it, but sometimes something would just click and I'd say, I just spotted a sensor, or someone mentioned something recently and that you just got that marriage, and that was the light bulb moment. So,
well, it's interesting. You say you work with your brother, and he's based in Sydney. I mean, how does that work? Working with your brother?
Working with your brother has its highs and its lows. It's there's strengths and weaknesses, and I'm sure he'd say the same. Time zone differences are very difficult as well, but we manage that. Yeah.
Well, you're based in London, and of course, as you said, you've come from an academic background, engineering before that. But how has your experience lecturing at UCL shaped your approach to innovation and product development?
I've got a long background in instrumentation, and I came into my lectureship with quite a lot of field experience, and it was really good to be able to instill that into the students. So
that's from CTRL, the Channels on Rail and Crossrail, of course.
Yeah, that's right. And I would run this. So I ran the engineering survey course, and we would run a field course, and just really kind of instilling on them the hardships and realities of, you've signed up to be a civil engineer. It's there is a field component to this, that you've got to be happy being wet and cold and muddy. And,
right.
Sort of preparing them for that. At that age, I think you just have bandwidth to absorb information, or at that stage in life. They were coming to me with all sorts of ideas and left field things. It was fantastic to be able to give them challenges and say what the pain points were on site and get insights from them. And that's really informed Osprey's business model, which is we design the sensors, and traditionally you would then sort of staff a factory with production technicians. We actually staff our factory with graduate engineers. And
right.
The intent is that 50% of the time they are production engineers, and 50% of the time they are engineers making that engineer's life easier. So we aim 50% of the time on the tools, 50% of the time improving those tools.
Oh, wow, yeah.
And then all of them have CSCS cards. All of them, we aim to get out on site at least quarterly, if not more, so that they are fully exposed to the realities of site.
Yeah, so they're actually being able to put live feedback into the product development, into the software development.
Indeed, yeah. People think that our real innovation is all the complicated maths and electronics, and that does come into it, but a huge amount is that screwdriver doesn't work in the mud.
Yeah.
This is fiddly when your fingers are cold.
Those
sorts of innovations. It's just at every level, and making and cutting out things in production as well, and just having continual innovation at all levels of the business.
A really interesting perspective. Of course, I'm also deeply fascinated by your work with the 507 specialist team at the Royal Engineers. What's that all about? How much of your time does that take up?
So it's a very, very unique team on many levels. It's part of 6.5 Works Group. So we're a Army Reserves regiment, so all part-timers, so to speak, supported by full-time Royal Engineers who do drilling works and sort of the more ongoing stuff for us. But essentially, we're all from industry. Lots of Network Rail people, lots of people in Network Rail adjacent industry. We provide a lot of NATO's core capability and knowledge base for railway infrastructure. It's maintenance, operation, support. So we do things like auditing how capable trains are of bringing tanks across different parts of the world, and how that could be undermined, what we need to protect. And the wider team is formed of, so we're rail, you've got ports, water, power, all of the kind of core national critical infrastructure components, and each of those draw from industry. So it doesn't take up too much time, and I've got a young family and a business, so they're very forgiving. When I was younger, I would spend a lot of time going around the world and helping support, but now I have other priorities, but they're very good at supporting different life stages. Now I kind of I'm wheeled out to give lectures on sort of special forces, what to do if you want to protect some infrastructure and things like that.
So it's more about protecting rather than undermining.
Both come into play.
Right.
to an extent.
Okay,
we
fine.
need to know it's good to understand vulnerabilities, to know what our vulnerabilities are.
Yeah. And does that see you actually going out on training missions in the field, so to speak? Or
so generally we'll meet every quarter. We have a railway facility that we can train at, and so we develop everyone to learn how to build and manage infrastructure. And then every year there's a 2-week exercise, essentially, where we'll then be deployed somewhere either in the UK, or this year it was US. Previous years it's been Germany or Italy. And we'll go out and then work with counterparties in other countries to then develop common railway doctrine. And in amongst the work groups also we have innovation groups. So we have domain experts from across industry and across the military as well, who converge, and we discuss how we can take the latest in, say, drone survey technology and bring that to military contexts. Sounds
fascinating. And but I suppose you get up to many other things. You say you got a young family. How young are your kids?
I've got a 1 and a 3-year-old. So
oh wow! Yeah. So you are very busy there then. So that presumably does take up most of your other free time then.
Indeed, yeah. I feel like we're hopefully just emerging from the trenches of the sort of the baby phase, so to speak. They're at least, you can negotiate with them now, at least.
Yeah, no. Well, there you go.
Delightful.
Well, yeah, good luck with that. I suppose it is a challenge when you're running your own business, I suppose, because at the moment, Osprey is in a huge growth phase. I mean, where do you see it heading over the next 3 to 5 years? Then is it new markets? Is it new products? Or is it all about new partnerships?
We're really establishing our first core products now, and I feel like we're in a position to be absolutely dominant within what I term the legacy instrumentation market. The next phase now is really starting to work with key collaborators, so Network Rail, National Highways type, with large German infrastructure firms, on how we can then package those to solve repeatable and scalable challenges. So specific earthworks challenges, specific dam uncertainties, specific long linear asset sort of uncertainties with power cables and fiber optic cables. We're also working with aerospace company. I'll give you one of 2 guesses on using our systems for measuring large scale jig fixtures to look at how airframes can be, how we can model and how we can understand the structural behaviours of large scale jig fixtures during production, so that we can sort of solve challenges with things nearing the edge of tolerance before they hit the end of the production line.
These are the kind of bits of kit that you build a wing against, maybe. Or
indeed, exactly. They are the size of civil engineering assets. So the domains cross quite neatly.
So is the platform scalable, or the production scalable? Because I imagine if you mentioned HS2, but then we're also looking at an awful lot of new, perhaps underground power cables that are going to be supporting the energy transition. I mean, these require vast numbers of kilometres of monitoring equipment. How do you scale up to meet that requirement?
Yeah, the main one is is densification at the moment. So we're working on that both in reducing sensor price, but also in innovating on drilling technologies. So we've been working with some pioneering drilling companies to look at how we can improve production rates from 1 borehole a shift to 6 boreholes a shift, for example.
Right, yeah.
And so we're now reducing the installation costs significantly. And we're looking at kind of telemetry. So there's huge advances in data and how to get data flows off-site. So we're working with companies on satellite systems so we can get data off-site much more easily. And then how to analyze that data. And a big piece of kind of where that comes in as well with what I'm doing with the Royal Engineers is in data sovereignty, data integrity. So, we've got a lot of national critical infrastructure that's being monitored by systems that, let's say, have fairly rudimentary security systems.
Right, yeah.
And as we found, there was a recent cyber attack on a dam in Norway where sluice gates were opened for a few hours before it was detected and closed. ultimately these systems are becoming increasingly critical they literally monitor national critical infrastructure. And you can imagine kind of the severity of a large rail embankment failure going undetected, or a reservoirs at the end of a dry summer being released. These systems actually they're quite critical and expose quite a large vulnerability for UK PLC and the UK society. So we're working very closely on how to improve that as well.
Presumably that means working with regulators and working with the asset owners, I imagine, to make sure that those systems are robust.
Indeed, yeah. So we've got very good relationships with all the key infrastructure owners, and for some they're really on this. So I would say anything to do with potable water is absolutely on it at the moment already. Other areas perhaps still in a bit reactive mode, but that's definitely where it's moving.
Yeah. Well, I mean, this whole issue of trustworthy data certainly continues to come up around the whole sector when it comes to trying to make sure that we are using data to boost the productivity and boost the outcomes from our infrastructure. Do you think we're getting there when it comes to trustworthy data?
It will always exist, I think, is the diplomatic answer. We're getting better at providing sensors that are reliable. I think people are getting better at installing sensors that are reliable. Designers are getting better at designing sensing systems that are going to detect what they want to know. So I think on an engineering level, there is huge improvement. I think there's also better detection of when data is unreliable. And then the security piece then comes in to manage against intentionally misleading information as well.
So just briefly to close, I mean, where do you think the big win is, Daniel? Is it about improving project delivery, because we continue to hear about the fact that we've got a lot of work to do, a big pipeline of projects to deliver to achieve the government's mission for growth? Or is it about improving asset operational performance, because you could argue that 95% of the assets are already built and it's just a question of running them better? Where's the big win for you?
Yeah, that's a great point. There is opportunity for improvement on the delivery side for sure. Most of it's above my pay grade and not necessarily where I'm involved. But yeah, you're absolutely right. The vast majority of infrastructure is installed, and huge costs are associated with renovating or remediating things that didn't need to be remediating, or spending budget on stuff that didn't need it instead of stuff that did. And what we're offering is a low cost way of understanding where those priorities may lie, or managing the risk associated with optimizing for one area instead of another. So I think that it is the effective management of this, of the existing infrastructure, and National Highways have been very clear that they're keen to learn the lessons of the railway operators, because ultimately they see themselves as kind of 10, 20, 25 years behind the railways, because railways were built Victorian era.
Yeah.
A lot of the highway stuff was, one generation beyond. And they're very conscious of that's what's coming down the road for them. So they're being really innovative in how they're starting to manage these risks. And Network Rail are really, I was super impressed the other day looking at a presentation by the senior geotechnical team at Network Rail on how they're using data that's available to quantify and prioritize what they want to manage. And I think that's going to have a huge force multiplier on how budget is used and allocated. And I think when that cascades out to highways operators, water, other kind of resource and core infrastructure within the UK, that will help us see a longer tail use of this legacy infrastructure.
Which ultimately, I imagine, is about your wider vision for the impact of OMS. It's a system which has that wider impact on infrastructure resilience and delivery.
Yeah, absolutely. And to get it from sensor to server to screen, and then have that decision maker being able to look at that and to make a decision. to deploy their resources more effectively, ultimately, is the name of the game.
Yeah, well, Dan, really, really interesting business you've got there. A really challenging set of problems you're dealing with on a daily basis. But thanks, for sharing your thoughts today. And I wish you huge amounts of luck. You've got certainly some great technology and some great projects and partners you're working with. So thanks for joining me today on the podcast.
Thanks, Anthony. Great to be here. Great to be involved in infrastructure. Great
stuff. Well, sadly, that's all we've got time for today on the podcast, but there is more in the pipeline as we continue to probe the big issues facing the sector. If you haven't done so already, do check out the Infrastructure Podcast website, www.infrastructure-podcast.com, where you'll find background information and all the latest podcasts to listen to and to share. So thanks for joining us, and thanks again to Daniel, and I look forward to seeing you again very soon.